Hi everybody. Today we're going to move on to a brand new learning target which involves performing operations on algebraic expressions. And so we just finished up talking about rules for exponents and order of operations. Now it's time to put it all together and perform operations on algebraic expressions. And when we say perform operations, we're talking about adding, subtracting, multiplying, and dividing algebraic expressions together. Algebraic expressions, you may hear me use the term polynomial. A polynomial in algebra is an algebraic expression, and sometimes I use those words back and forth. Sometimes I'll say polynomial, sometimes I'll say algebraic expressions. Just note that means the exact same thing. So we're going to start with adding polynomials or adding algebraic expressions together, and this is something that you've probably seen in the past. And most oftentimes you hear people describe what's going on here as combining like terms. Combining like terms in algebra means, first of all, if we talk about the word terms, just note that algebraic expressions are broken into terms, and each term is separated by addition and subtraction. Let me just show you an example here. If we look at this middle algebraic expression or middle polynomial here, you'll notice that there are 1, 2, 3 terms, and each of those terms is separated by either addition or subtraction. So when I use the word term, I'm talking about a part of an algebraic expression or part of a polynomial. With that being said, when we're adding algebraic expressions together, what we're doing is we're combining like terms together. And what do we mean by like terms? Like terms are terms that have the same variables and exponents. Terms that have the same variables, same combination of variables and exponents. So we're going to be on the lookout for these because these are what we're actually going to be combining together. And by combining, I mean adding or subtracting from one another as we add algebraic expressions together. Let's take a look. We're going to do some examples here. Let's take a look at adding algebraic expressions together. I'll use a little bit of highlighting here to show you which terms are like terms. So if we look closely at number 1, we see the expression x minus 6 plus 1 plus 6x. You'll notice some of the terms here have an x and some of the terms do not. These are the like terms. So let's start with the terms that do have just x, right? And when I'm highlighting here, I want you to pay close attention to the sign that actually that's in front of the term, because the sign indicates whether or not we're going to be adding or subtracting the terms from one another. So remember, when we have just x, that means 1x. So what is 1x? 1x plus 6x, that would be 7x. Then let's go ahead and combine the terms together that don't have any x's. We have negative 6 and positive 1. Negative 6, and that would be a positive 1. Negative 6 plus 1 would be negative 5. And we're going to represent that negative 5, that negative part, with a minus. So we have 7x minus 5. We could have written 7x plus negative 5. We could have done that, but what we're going to try to do is get into the habit of not having double operators here. We can combine them together as a single operator. If we're adding a negative, that would be equivalent to subtracting. So why not just write it as 7x minus 5? So I don't really want the double operator there. I really want you to put those together and leave it as just subtraction. Let's look at another one. Okay, so this one is a little bit more complex because now we have 3 polynomials we're putting together and lots of different like terms. So let's organize the like terms together. So we have 8x to the 4th. Now we're going to move down the line and we're going to see if there's any other x to the 4ths anywhere. In the second polynomial, we do see plus x to the 4th. Don't forget that's plus 1x to the 4th. And I don't see any x to the 4ths in the third polynomial. So let's go ahead and combine them together. 8x to the fourth plus 1x to the fourth is 9x to the fourth. Then let's move down and let's do the x to the thirds. So we have positive 5x to the third plus negative 6x to the third. If we combine 5x to the third plus negative 6x to the third, we get negative 1x to the third. We're going to write that as minus 1x to the third. Minus x to the third. Continue on down the line here. Let's move on to the x squareds. We got negative 6x squared plus 4x squared plus positive 4x squared. Negative 6 plus 4 is negative 2. So that would be negative 2x squared. This would be an interesting time to just stop and make note of what's actually happening here. Notice that when I'm combining like terms together, I am only combining the coefficients of the terms together. I am not doing anything with the variable or the exponent. I'm not adding the exponents. I'm not multiplying exponents. I am only combining the coefficients of each term together. So when we had 8x to the fourth plus 1x to the fourth, all I did was add 8 plus 1, and I left the x to the fourth as is. Coming back to our problem here, there is one more term. You notice that it's not highlighted. See that right here? Plus 6, positive 6. So there's nothing to combine that with. We are just going to stick that on at the end by itself. Now, as we work through this, notice that we started with the terms that had the highest exponent, 4, and we worked our way down to the lowest exponent, where the 6 didn't have any exponent at all. When we write a polynomial in this order, notice it starts from the highest exponent, and then each term gets lower and lower and lower in exponent. This is called descending degree order. Descending, meaning going down, degree referencing the exponent. Descending degree order. And this is one of the most common ways that we actually write algebraic expressions. We write them in descending degree order. Some people will also call those standard order. Standard order is descending degree order. So you could hear it either way. Standard order or descending degree order. All right, so these two examples involve adding, right? In each case, we had an addition sign in between each polynomial. Now let's take a look at subtraction. So if we look at subtraction, we notice that we have a minus sign, and then we have a set of grouping symbols. What that's telling us is that every term in that group now needs to be subtracted. Let me repeat that. Every term in the grouping after the subtraction sign needs to be subtracted. Some people like to think of this as, well, okay, in this case, I'm going to subtract the 5x squared, and I'm also going to subtract the negative 3x to the fourth. So I'm going to subtract both of those terms. What I recommend doing then is rewriting this as one string of polynomials without like terms combined together. So here's what I mean. We don't need to touch anything in this first polynomial. So we're going to rewrite it as 3x to the second minus x to the fourth. And now we're going to go ahead and we're going to rewrite what's next, subtracting each of the terms. So minus a positive 5x squared would be minus 5x squared. And then minus a negative 3x to the fourth. When we subtract a negative, that would be the same as adding. So this becomes plus 3x to the fourth. Again, so each term, the positive 5x squared became subtracting, and then the negative 3x to the fourth became subtracting. Minus a negative is a positive. And now if you take a closer look, this kind of looks like the distributive property, right? Distribute. And really, that's kind of what I'm doing here. There is a little like a ninja 1 in here. little minus 1. And really what we're doing is we're distributing that negative 1 or multiplying each of those terms by negative 1 when we're subtracting each of those terms. And now that we've distributed the negative 1, or we've subtracted every term, we're going to go ahead and combine like terms together. So remember how we said descending degree order? Let's start with the x to the 4ths. So we have negative x to the 4th plus 3x to the 4th. Negative x to the 4th, or negative 1x to the 4th, plus 3x to the 4th is 2x to the 4th. Let's move on down. 3x squared minus 5x squared. 3x squared minus 5x squared is negative 2x squared. So we're going to write that as minus 2x squared. Now, we cannot combine these two terms together because they are not like terms, right? One is x to the 4ths, one is x squared. So we are done. And this is as far as we can go with simplifying this expression. We're going to do one more, okay? This time you'll notice we actually have two subtractions. So we are going to distribute a negative 1 through each of those two terms, and we're going to distribute a negative 1 through both of those two terms. Once we do that, let's rewrite, okay? So nothing happens with the first set. So 6n minus 2 plus 4n to the 3rd. And now let's go ahead and distribute that minus through the parentheses. So negative times 1, or minus 1, minus 1, minus a positive 8n is minus 8n. And then we have minus positive 4n to the 3rd, or minus 4n to the 3rd. And then minus 3n, that would be minus 3n. Now it's time to combine like terms together. Let's start with, what's the highest exponent you see? N to the 3rd. So let's go ahead and let's combine the n to the 3rd terms together. Ooh, this is interesting. Positive 4n to the 3rd minus 4n to the 3rd is 0n to the 3rd, or 0, right? They cancel each other out, so those we can say bye-bye, no more. Let's move on down. So do we have an n squared? Nope, no n squareds. Do we have any n's? Yes, here's one, 6n. Here's another one, minus 8n, and one more, minus 3n. Combining those three things together, 6n minus 8n is negative 2n, minus 3n would be negative 5n. So negative 5n's. And lastly, negative 2 minus 1 would be negative 3. So we have minus 3. Can't do anything else with this. Those aren't like terms, so no more combining. This must be our final answer. So in this video, I'm going to split this into two parts. We're going to just stick with addition and subtraction in this video. I'll make a separate one for multiplication and division. But let's just recap for 1 second. When we were adding polynomials together, we just combined like terms, right? Combining like terms and writing our final polynomial in descending degree order. That means from the highest exponent, down to the lowest exponent. Highest exponent to lowest exponent. This is also called standard order. And when we were subtracting polynomials, we needed to remember that we had to actually subtract every single term in the group that comes after that minus sign. And we almost treated that as the distributive property. We almost distributed a negative 1 through. And once we did that, we can combine all our like terms. All right. So that's the end of this video. You can continue on and watch the multiplication of polynomials. We'll look at these 4 examples in the next video.